So let's start with strong acids. If this is a strong acid, we actually usually call HA a weak acid, but just for example here, if that was a strong acid, we would have HA plus H2O, and what would the two products be completely? What do you think? H3O plus, yep, H3O plus, and A minus, yep. And again, most important part here probably is that forward arrow. Okay? There will be no HA left over in a strong acid. It will have completely ionized into hydronium ions and A minus, the conjugate base of that strong acid. Okay? So if that was HCl, we would have chloride ions, but it would all be made into hydronium. That would be the acid part. Okay? So therefore, for every 1 mole of strong acid that we dissolve, we produce
1 mole of hydronium, 1 mole of A minus.
Yep. Although that A minus is going to turn out to be just a spectator ion, like chloride, that will not have any. When we classify the acidity and basicity of ions later on, we'll get to exactly that. But the spectator ion that comes from a strong acid will just end up be floating there. So chloride ion, for instance, has no impact on the acidity of a solution, turns out. The autoionization of water also produces hydronium, just sort of on its own, but this is negligible in strong acid solutions. That is on the scale of, here, that's this. That would be on the scale of 10 to the minus 7 molar or something like that. But strong acids, we usually will have like 1 molar or 2 molars or 0.5 molars or something like that. Several powers of 10 more than what's produced by water itself. Okay? So that makes our calculation pretty simple. For the pH of a HCl solution, HCl is one of our strong acids, so we could say HCl is 0.10 molar, but what more importantly is also 0.10 molar.
The hydronium.
Yeah. Okay. So, what would we do for pH? P function. Negative log of 0.10. 0.10 is 10 to the minus 1. So the negative log of 10 to the minus 1 is just 1. But because there were 2 significant figures in that concentration, our answer will not be just 1, it will be what? 1.00. Those 2 significant figures became the 2 decimal places in that concentration. Okay. So, if all we would have said was 10 to the negative 1, that's no sig figs, that would have been pH of 1. Okay. This would be 1.0 times 10 to the negative 1. So those 2 digits end up sort of over here. Okay? But it's still right on the value, so these haven't changed the numerical value. It's just added significant figures to it, essentially.
So if it says 1 molar, that says pH equals 1.
If it said 1 molar, no, 1 molar is 1 significant figure. Yeah, that would be, yeah. So 1 molar pH would be negative 1.0. Okay. 10 to the, no, pH is 0. 1 is, yep, okay, 1 is 10 to the 0. There we go. Okay, 1 molar would be 1 times 10 to the 0. There we go. That'll teach me to try to do things in my head. Okay? So pH would be 0. Well, and then how you put the sig figs for 0 is kind of a question. I would probably do 0.0. Put the 1 decimal place there. There we go. What would a pH of 10 molar be? Think of this. We had 0.1 molar, that was pH of 1. 1 molar, that was pH of 0. 10 molar would be pH of -1. Yeah. It's okay to have pHs outside of the 0 to 14 range. It's usually going to be very concentrated. Okay? One 1.0 times 10 to the 1.
It wouldn't be -1.00.
Yeah, well, if it was 10, if that was 2 sig figs worth, that's why I put the little decimal point there. That would be -1.00. Okay. So there's examples of all the various numerical ways that we deal with that. Okay? But mostly what I wanted you to get down here is pH of 0.1 is, or concentration of 0.1 molar, pH of 1, concentration of 1 molar, pH of 0, concentration of 10 molar, pH -1. What would the concentration have to be to get pH of -2?
20 molar.
No. It would have to be 10 to the 2, right?
So 100 molar?
Yeah, it would have to be 100 molar, which I don't think you can usually get. So if your calculation has told you a pH of -3 or something like that, you probably did something wrong. You probably more likely just didn't do the negative sign there, and you're actually getting a pH of 3 or something like that. Okay? So HCl solution, 2.5, 10 to the -3. What is that pH?
160.
Yep, 2.60, pH -log. 2.5, 10 to the -3, 2.60. Okay. We can do that with any strong acid. What would be the pH of a 2.5 times 10 to the -3 molar nitric acid solution?
Say that again?
Nitric acid. Here, there's our list of strong acids. Same concentration, but if it was nitric acid,
So same answer.
same answer. Same concentration for any of these strong acids would give you the same pH, in water at least. Okay? That's because our definition of a strong acid is that it completely ionizes. 1 mole of any of these would make 1 mole of hydronium ions in water. Okay? That makes sense?